So looking here at note 7.4, we have the quotient property of powers, and we know the word quotient there means division, okay? So our essential question is, can I divide powers with the same base? And what we're getting ready, or what I wrote down first, please star it, highlight it, underline it, memorize it. We all should already know this. Any number or letter divided by itself is 1. So 5 divided by 5 is 1. Negative 10 divided by negative 10 is the number 1, the whole number 1. 17 divided by 17 is 1. A divided by A, it can be letters, is the whole number 1. So we can also go and write these out. So I'm going to write out example 1 here. It says 4/5 divided by 4/3. You know I'm a big proponent of writing the problems out. So 4/5 is 4 times 4 times 4 times 4 times 4. I got 5 of them. And on the denominator, we have 4 times 4 times 4. And so the whole reason we reviewed 4 divided by 4 would be a whole number 1. And 4 divided by 4 is 1. And 4 divided by 4 is 1. And what do I have left? I have 2 4s in the numerator. They're located in the top. We could write that as 4 squared over the whole number 1. 1 times 1 times 1 is 1. And so this would just be 16. 4 squared, 4 times 4 is 16. So let's think about the rule here. How could we get that? Well, our rule for this problem is that if I have the same base, so a to the power of x divided by same base, a to the power of y, we can subtract those powers, x minus y. We can subtract those. So 5 minus 3 in the problem above gets you 4 squared. Let's try using the rule here. I love writing these out, but let's try using the rule to simplify these. I'm going to actually do this both ways. Never mind. Let's do this both ways. Let's start by writing it out. So I have m times m, n, 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 and n, divided by 5 m's, 3 n's. And so remember, anything divided by itself is 1. So I've got a number 1. I've got a number 1, and now let's go to the m's because I have no more m's that can cancel out to make 1. And these all make the number 1. So what do I have left? Well, I have an n left in the numerator. And in the denominator, I have 3 m's. And that would be m cubed. And that would be our final answer. Write it out, and we know that we can simplify because anything divided by itself is 1. Let's go ahead and use the property or the rule that we just learned, the quotient property of powers rule. Let's look at our m's. This is saying m2 minus 5, because we're subtracting them because it's division, and n4 minus 3. And if we simplify that, 2 minus 5 is an m negative 3 and n1. But remember, we don't want a negative exponent. If it is simplified, we cannot have a negative exponent. So I'm going to make this a fraction, and we're going to go back to our exponent rules. When we have a negative exponent, we know we have to move it. And so we would get the same answer, n to the first power in the numerator and m to the third power in the denominator. So 2 different ways of looking at the same problem. I always suggest you can write it out, but hopefully we start to understand the rules and we can subtract those exponents because it's division. Let's go ahead, and example 3 probably looks a little different. I just want to make sure we remember how to simplify fractions. That's it. What can divide into 15 and 25? Because we do need to make sure that we can simplify. We can divide the numerator and the denominator, nope, not by 3, sorry, by 5. Dividing it the same, we're simplifying it. And so what do we get if we're dividing by 5? Well, we get 3/5. So just making sure we know how to simplify just plain old fractions. That's going to be important for us to look at our next problem. To summarize our rule of quotient property of powers, dividing them or subtracting the exponents. That's it. And there's a lot here. This has got a lot of the properties in it. So I want to remind you that the 2 has an exponent of 1 and the 4 has an exponent of 1. The x has an exponent of 6 and the y has an exponent of 4. And we have the power property here, power to a power. So I'm going to write it out. We're going to have 2 to the negative third x. We're multiplying these. 6 times negative 3 would be negative 18. Power to a power means multiply. Let's look at our denominator. We're going to have 4 to the negative third power. And 4 times negative 3 is going to be y to the negative 12. And what we notice here is we've got a lot of negative exponents. Everything's going to move. This goes to the bottom. This goes to the bottom because we want positive. This goes to the top. This goes to the top. So we have 4 cubed in the numerator. Y12 becomes positive when you move it. 2 cubed x to the power of 18. So my y's and my x's are the same, are like different letters, so we can't simplify those, but let's go ahead and simplify the 4 cubed and the 2 cubed. We could write it out as 4 times 4 times 4, y12, divided by 2 times 2 times 2, x18. And if we actually go ahead and just multiply those together, we're getting 64 in the numerator, y12, divided by 8x18. And when we simplify, we know 64 can be divided by 8. So our final answer here would be 8y to the 12th power divided by x to the 18th power. So looking at our